have you ever noticed how leaves in hot, humid climates like the tropics are much, much larger than the average leaf in a colder or drier climate like up in the mountains or the desert? Why is that? Well, it turns out it all has to do with something called a boundary layer. So, the boundary layer is this small pocket of air that sits on top of a surface, and it's much slower than the rest of the air that's above that pocket of air. And the reason for this is that whenever air slides over an object, that object provides friction, slowing the air down, and it creates this velocity profile where the air is getting faster and faster as you go farther and farther up from the object. But point is that there is a boundary layer on most leaves, and as you go farther along a leaf, a larger leaf, for example, the boundary layer thickens. And this boundary layer provides a lot of insulation. So because it's sticking to the object, it actually has the same temperature of the object, and it doesn't really allow for much heat transfer. So what that means is a larger leaf, which has a thicker boundary layer, will have a lot more insulation than a smaller leaf, which has a thinner boundary layer. And so based on that, we would typically expect that these insulative leaves, like banana leaves, would do well in cold climates. But if you think back in your head, have you ever seen a banana leaf up in the mountains? No. And so, weirdly enough, the leaves with the most insulation tend to be found exclusively in hot and humid areas like the tropics. To understand this, we have to understand how plants regulate their temperature. So when it's cold at night, unlike us, plants don't try to hold on to their heat. Instead, they actually try to absorb heat from the surrounding air, from the ambient temperature. The reason for this is that they lose most of their heat to the night sky through long wave radiation. So as you can imagine, a plant that has more insulation is actually going to struggle to absorb that heat from the surrounding environment. Whereas a plant like a pine needle with little to no insulation will be able to absorb that heat just fine.
A big leaf in very cold nighttime conditions, the temperature of that leaf can drop way below the temperature of the air. So like say the air temperature is 0 degrees Celsius. On a cold, clear night, that temperature of that leaf can drop down to maybe -5, -7 degrees. And that is so cold that leads to radiative frost damage. So the leaf freezes, the ice crystals form in the leaf, it disrupts the cell membranes and destroys, there can be irreversible damage.
Whereas a small leaf plant has its temperature stay the same as the ambient. It basically tracks it. Now let's talk about deserts. Like cold areas and mountains, leaves tend to be really small in the deserts. And the reason, again, has to do with temperature regulation. Except here, it's the opposite. Instead of trying to prevent frostbites, plants have to try to prevent overheating. The two ways plants can stay cool are convection, by losing heat to the ambient air, and transpiration, which is essentially plants' way of sweating. Transpiration is what happens when plants exhale water vapor and let in carbon dioxide as part of photosynthesis. Now, this exhalation of water vapor leads to evaporative cooling, which releases a lot of latent heat and cools the plant down. Now, in the desert, there's not a lot of water, so transpiration isn't really a major cooling method, and so it's pretty challenging for a leaf that has a lot of insulation to lose heat to the ambient air. And so a larger leaf, which has more insulation, would really struggle to prevent overheating in a desert. And that's why they're not that common.
When you go to a desert, for example, you just don't see large leaf species, except you'll see some, like, unless they have like their roots down into very deep water, or maybe they're deciduous or something, so they only have their leaves there for part of the year when there's water around.
So the two factors that constrain leaf size are a lack of water or an overly cold climate. In the tropics, where it's hot and it's humid, these constraints no longer apply, right? There's a lot of water to do transpiration with, and it doesn't get cold at night. And so basically, nature allows these plants to get really big. and their leaves are able to get really large so that they can do a lot of photosynthesis and produce a lot of sugar, which is what plants eat.